Hello, everyone, and welcome to another episode of the Day 1 to Deep Tech podcast series, where we explore the people, technologies, and real world stories behind today's most exciting engineering careers. Today's conversation is about autonomous robotics, a field that's transforming industries around the world. From warehouse robots moving thousands of products every hour to autonomous delivery vehicles, agricultural robots, inspection drones, surgical robots, and self driving machines, robotics is no longer something we only see in science fiction. It's becoming part of everyday life. But have you ever wondered what it actually takes to build a robot that can think, sense its surroundings, make decisions, and move safely through the real world? To help us answer that question, we're joined by the founder of a robotics startup that designs and develops autonomous robotic solutions for industrial and commercial applications. Thank you so much for joining us today.
Thank you for having me. I'm really excited to be here because robotics is one of those fields that sparks curiosity in almost everyone. Whenever people hear the word robot, they immediately imagine humanoid machines walking around like they do in movies. The reality is actually much more fascinating. Today, robots are quietly working inside factories, warehouses, hospitals, farms, construction sites, airports, and even underwater. Many people benefit from robotics every single day without realizing it. I'm hoping that by the end of today's conversation, everyone listening will understand not only what autonomous robotics is, but why it's becoming one of the most exciting engineering fields of our time.
That's a fantastic place to start. Let's go back to the beginning. Did you always dream of becoming a robotics entrepreneur?
Not at all. Like many engineering graduates, I was fascinated by technology, but I didn't know exactly where I belonged. During college, I experimented with different areas. I enjoyed programming, electronics, and mechanical design, but I saw them as separate subjects. Then one day, our college organized a robotics competition. Our team built a small robot that had to navigate a maze. It wasn't very sophisticated. It bumped into walls, got stuck in corners, and sometimes refused to move altogether. But watching a machine respond to the world around it was unforgettable. That was the moment I realized robotics wasn't just about writing software or assembling hardware. It was about bringing multiple engineering disciplines together to solve real world problems.
That's interesting because many people think robotics is just mechanical engineering or just programming.
Exactly, and that's one of the biggest misconceptions. A robot isn't just a machine, it's a complete system. It needs sensors to observe the environment. It needs software to understand what those sensors are detecting. It needs algorithms to decide what to do next. It needs motors and actuators to perform physical actions. And it needs reliable communication between all of these components. Robotics sits at the intersection of mechanical engineering, electronics, embedded systems, computer science, artificial intelligence, and systems engineering. That's what makes it both challenging and incredibly rewarding.
What happened after that robotics competition?
I became curious. Instead of simply asking, how do I make this robot move? I started asking much bigger questions. How does a robot know where it is? How does it avoid obstacles? How does it decide which path to take? What happens if its sensors disagree with each other? How does it continue operating if part of its environment changes unexpectedly? Each question opened the door to an entirely new area of robotics. I didn't know it at the time, but I was beginning to explore concepts like localization, sensor fusion, path planning, and autonomous navigation.
Those are topics many people will eventually learn, but it's great to hear how they emerge from simple questions. What was your first professional role?
I joined a robotics company as a junior robotics engineer. To be honest, I imagined I'd spend every day programming exciting robots. The reality was much different. Some days I calibrated sensors, some days I updated firmware, some days I spent hours analyzing robot logs to understand why a navigation test had failed. Other days, I helped assemble prototype hardware or tested robots repeatedly under different conditions. I quickly learned that robotics is built on patience. A robot rarely works perfectly the first time. Every test teaches you something.
That sounds very different from what people see in promotional videos.
It definitely is. Videos usually show the final successful demonstration. They don't show the dozens or sometimes hundreds of tests that happened before that. Behind every smooth robot demonstration are countless hours of debugging, experimentation, redesign, and teamwork. That's one of the things I love most about robotics. Progress comes from continuous learning and improvement.
Was there a moment when you realized robotics was going to be your long term career?
Yes, a few years into my career, our team deployed an autonomous mobile robot inside a warehouse. For weeks, we'd been testing navigation, obstacle detection, and task execution. The first day, it successfully transported materials across the warehouse without human intervention was incredibly satisfying. It wasn't because the robot was moving, it was because we knew how many different engineering challenges had been solved to make that moment possible. That experience changed my perspective. I realized robotics isn't about building impressive machines, it's about solving meaningful problems that improve safety, efficiency, and productivity.
Many people assume robots replace humans. Has your experience been different?
Very much so. The best robotics applications don't replace people, they support them. In warehouses, robots handle repetitive transportation tasks while people focus on planning, supervision, and quality control. In hospitals, robots assist medical professionals by transporting supplies or supporting delicate procedures. In agriculture, robots help monitor crops and perform repetitive tasks, allowing farmers to focus on decision making. Robotics changes how work is done. It doesn't remove the need for skilled people. Instead, it creates new opportunities for engineers, technicians, operators, and innovators.
Looking back, what was your biggest misconception before entering the robotics industry?
I thought building the robot was the hardest part. In reality, making a robot reliable in the real world is much more challenging. A robot may work perfectly in a laboratory, but place it in a busy warehouse, a dusty construction site, a noisy factory, or an outdoor farm, and suddenly everything changes. Lighting changes, weather changes, people move unpredictably, objects appear where they weren't expected. Robots have to handle uncertainty every single day. That's what makes autonomous robotics such an exciting engineering challenge.
If you could go back and give your younger self one piece of advice, what would it be?
I tell myself to stay curious and build more projects. Don't wait until you think you are ready. Experiment, break things, fix them, ask questions. Every robot you build, no matter how simple, teaches you something valuable. The fundamentals you learn from a small project often become the foundation for solving much bigger problems later in your career.
That's a wonderful message to begin today's conversation. We've learned that robotics isn't just about building machines, it's about combining engineering, creativity, teamwork, and problem solving to create systems that can safely interact with the real world. In the next segment, we'll talk about the realities of working in robotics. We'll discuss what textbooks don't tell you, why robotics is one of the most multidisciplinary engineering fields, and naturally explore concepts like sensors, ROS, SLAM, localization, sensor fusion, and path planning through real industry experiences. Stay with us.